You had to perform a calibration on your Conspec Controls Universal Series monitor. You need some basic equipment. First being your calibration cylinders, your span gas and your zero gas, your calibration adapter, your flow regulator, gas tubing, and your infrared handheld programmer. Before you start your calibration, you want to make sure that the monitor is unlocked. We do this by entering the function 25, enter, and the monitor will ask you for the password. Default is set to 1, enter. Now the monitor is unlocked. So we can begin connecting our calibration fittings to prepare for the calibration. So we want to thread on our flow regulators. These particular regulators have a thumb wheel to activate the gas. To do so, you want to depress the thumb wheel and rotate it 90 degrees, and then backwards, shut it back off. Connect our calibration tubing. It's a good practice to, when you connect your calibration cup, do that before you run the tubing over so that you don't unthread your tube barbing. And typically our monitors ask for zero gas first, so we can go ahead and connect our zero gas cylinder. Okay. Before we begin calibration, we want to verify that we have the proper gases and that the monitor is programmed to accept the proper value. This is a 0 to 100% LEL monitor for methane, and we're using 2.5% methane, which is half of the LEL. So we want to verify that this monitor will accept that gas. To do so, you want to enter the function 100, press the enter key. Gas type's not relevant for calibration, so we can skip past that. Then the next screen displays range 100. As I said, this is a 100% LEL. That's what the 100 corresponds with. Press the enter key. Span value equals 50, which is correct in that we're using half of the span to calibrate. And then the rest of the screens, again, are not relevant, so we can advance past those and get the monitor back into monitoring mode. So now we're ready for calibration. To initiate your calibration, you want to enter the function 111, 3 ones, and the monitor will ask for zero gas. This time we can turn on our zero gas. And since this cylinder contains a gas that's very similar to our ambient atmosphere, you may not see much of a change in the number. The reason that we inject a gas that's similar to our atmosphere, we're letting the monitor experience a true zero condition that's free of the target gas, in which case would be methane here. And we're looking for more of a stable reading and a numeric value here. As long as your first 3 significant digits aren't fluctuating, it's a good indication that it's a stable reading. So we can go ahead and accept that value and then shut the calibration gas off. It's a good practice to accept the reading before you shut the calibration gas off in order to ensure a true reading. So at this point we can connect our span gas. We can turn on our cylinder. At this point we should start to see the value rise. It's a good idea to write down your values both for your zero and your span so that you have a reference when you're doing your calibrations and you'll know what to expect. Over time, as this sensor depletes, the output diminishes, so your values are going to shift a little bit, and it'll be a good indicator that your sensor's working towards failing. Our Universal Series will not allow for bad calibration data to be entered. So if you've accidentally grabbed the wrong gas or you haven't set the programming functions correctly, the monitor will not accept the data and revert back to the original calibration. So it's a good fail-safe measure. This value that we're seeing here is a pretty good value for a 0 to 100% LEL. Looks fairly stable. It is increasing. For the sake of calibration, we can enter this value. We could let the gas stay on for another minute or so to get a higher reading, but this looks pretty good. So now we see the cal done message. We can shut our gas off. And we want to disconnect the calibration adapter to get fresh air into the sensor to allow it to recover. Now the reason this cal done is displayed, it allows the monitor to recover. If this monitor were connected to a central control system where alarming procedures could be initiated by high methane readings, we wouldn't want anything to happen, so we let that recover until it gets down below the alarm point that we programmed in. And as I mentioned before, our monitors would not allow for a faulty calibration to be entered if we did grab the wrong gas or we entered the wrong programming into that 100 function. We would have gotten a calibration error message instead, at which time it would revert back to the original calibration. Here we can see it's slowly decreasing. It usually takes maybe up to a minute to recover, but once you're back down at 0 and you're in monitoring mode, you're finished your calibration.